On Monday, we completed about this linear recursion. So let me just repeat a little bit about the linear recursion. So this is a problem about computing square. Computing square means I have a number, let's say x, and I want to do the exponent, x power of n. So we can derive a more efficient linearly recursive algorithm by using the repeated squaring. So the repeated squaring means if it is 0 for the x, if it is 0, then return 1. If x is higher than 0, if it is odd, then you can do this formula by putting the x exclude from the exponent. So you can see here, if it is, let's say, 2 power of 5, then it means I can do with 2 multiplied by 2 power of 4. So this is the meaning by that one. And if it is even, so let's say this is 2 power of 4, then we can do with the division by 2. So for example, this is 2, and then we have 4 divided by 2 power of 2. So you can see, let's say if it is 2 power of 4, then it is the same with 2 power of 4 divided by 2 multiplied by 2. So using this one, it means I can have 2 power of 4 divided by 2 power of 2. So it is the same with this one. Then we can have the short version for power of 2. Then the result is 16. If it is 2 power of 5, then it means 2 power of 1 plus 4 divided by 2 multiplied by 2. We know that 2 power of 1 is 2. And then 2 power of 4 divided by 2. And then we want to do the exponent with 2. So 2 multiplied by 2 power of 2, then the result will be 2 multiplied by 4 power of 2, and it is 32. So this example explains about this formula or this equation. You can check on the 2 power of 6 and 2 power of 7. So the idea is the same. So the algorithm, if we want to use the recursive, it means we can have the algorithm power x comma n. So x is the number, and the integer n, we can have any number. Let's say the base case n will be q. So the output is the value of x power of n. If n equals to 0, then return 1. If n is odd, so of course this is pseudocode. Okay. If n is odd, how do we know whether n is odd or even? Then we need to do something like n remainder 2. If n remainder 2 equals to 1, then it is odd. If n remainder 2 equals to 0, then it is even number. Bulsu Chatsu. This is pseudocode, so we just make it simple like this one. And if the n is odd, we will do like this one. And we will just return x multiplied by y multiplied by y. So we call again the power, which is the algorithm, or this is the function. Else y equals to power x n divided by 2. So this is the algorithm name. Because it is, we have the base case, okay? We have the base case, and then we have the recur, and the recur only one, and we call this is linear recursion. So for the analysis, yeah, each time we make a recursive call, we half the value of n. So here we make half. Half means we divide by 2. Here we divide by 2. So the operation will be half. Then we make log n recursive calls because it is half every operations. So this is not n. So maybe you know the ON means the linear, because we want to make it as half, then probably it is because it is half, so we can approximate the operation that it will be log n. So that is, this method runs in O log n time. But in this case, we use a variable twice rather than calling the method twice. So we use this one and we use this one. So we use twice. Yeah, this is also one of the example for the linear recursion. We have only one, but we can also call several times. So there are some other variants of the recursion. So we will check the tail recursion, binary recursion, and multiple recursion. We will look at the tail recursion and binary recursion, but for the multiple recursion, I will just skip this one. If you have interest, you can look at the book. The tail recursion. Tail recursion occurs when a linearly recursive method makes its recursive call, x is last step. So tail recursion is the linear recursion. The linear recursion means we have base case and we have the recur only one. And it will do the recursive call until the last step. So the array recursion method is an example. If you still remember, the iterative reverse array, it is the example of the tail recursion. Such method can be easily converted to non-recursive methods. You know, what does it mean? Non-recursive methods. So some of the methods we can use recursion, but some other method we can use non-recursion. Non-recursion means we just use the for function, or this is the iteration. So some people said it will save on some resources. So if it is possible to make as the recursion, or if it is also possible to make it as a non-recursion, we can say this is a variant of the tail recursion. It is the tail recursion. So one of the example for the tail recursion is this one, the iterative reverse array, the swapping. Okay? So we swap the array. As Monday, we learn about this swap array. So this is example. If you use the iterative reverse array with recursion, you can do with this one. If start is higher than or equal to n, return the array. So otherwise, we will do the swapping. So array start will equal to be the array n, and array n equals to the array start. And then we do the reverse array. Start will be added by 1 and will be minus by 1. And this will run again the function. If you do with the non-recursive method, then you can use one array and then you define what is the starting point and what is the ending. So the ending means it is based on the length of the array minus 1. And we check if the start is less than the end, then do the swapping. So we do the swap. And then start will be added by 1 and will be minus by 1. So those two are giving the same result. But this one with recursion, this one with non-recursion. So which one is better? I'm going to show you. Maybe for you it is easier to see this one. But actually many developer they want to use this one because it is more complex or it is shorter. And in some of the algorithms you will see like this one. Many algorithms they try to use the recursion to make the algorithm shorter. The other kind of variance is the binary recursion. Binary recursion means we have two kind of recursive calls. We have two recursive calls for each non-base case. So here we have the binary sum problem. Okay? So the problem is add all the numbers in an integer array A. So I have this array 2, 4, 5, 7, 8, 9, 12, 14, and 17. So I want to add those numbers. And I want to add those numbers by splitting the numbers. So if you still remember the binary search. What is binary search? In binary search, we select the mid value. After we know the mid value, we split into right or left. So it's just the same. We check the mid value. So we check how many data do we have, and then we split the data on the left and the data on the right. So you can check here, if n equals to 1, then return AI. If not, then return the binary sum, which is I until n divided by 2. So let's say n is 8, then 8 divided by 2, it is 4. Then I will do the repetition for the binary sum from 0 to the n divided by 2. The binary sum is the function name. The other binary sum is the a from I plus n divided by 2 until n. Sorry, this is not n divided. So it is n. Oh, sorry. This is the same. Okay. This is sorry. This is still the same. N divided by 2 because I want to check the number of data. So because I have 8 data, so I want to start from the index 0 until 8 divided by 2, which is 4. So it means I will do the range from 0 until 4. And then for this one, I will do the 4 until 4 items. So it means 0 until 4. This is 1, 2, 3, 4, 4 items. And then the remaining will be 1, 2, 3, 4, the other 4 items. So this is the numbers of data that I would like to check. Because we have binary sum on the left and binary sum on the right, so there are two recursive calls. So we call this is binary recursion. So this binary recursion will run something like this. If I have the data 2, 4, 5, 7, 8, 9, 12, 14, then the left will be 2, 4, 5, 7, and the right will be 8, 9, 12, 14. And then I split again this into 2. So divided by 2, left and right. And then I will again divide by 2 until we have only one element. So we will go back and do the summation. 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 So the same with the right section. After we complete until the element equals to 1, then we will do the summation. 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 And then at the end, we will do the overall summation. So I give you the link of the code here. You can check this one. So here you can see the step by step. So this is the step by step of the algorithm. So how the algorithm do the addition? So here you can see the data. It is 2, 3, 5, 7, and 11. And then if you click on this next, so it will show you how this algorithm works step by step. So you can see the red color means now we are doing the algorithm at this steps. And then in the states, and then in the states, and then in the states, and so on. So we will check for every of this one until the last, and we will get the value which is 28. So this is a simulation how to check the operations. So you can check by yourself for this one. So the other kind of recursion for we can also see, if you know the tail recursion. What is tail recursion? The tail recursion is the recursion method that can also be a non-recursion method. So if you can change to a non-recursion method, that can be say as the tail recursion. And usually we have the recursive call happens in the last. So if the recursive call happen in the last, so we call this is till. Till. Till means full. So at the end. The other is the binary recursion. We have two recursive calls. So two recursive calls like the binary sum. So the other kind of recursive function we can see from the Fibonacci. I think some of you already know about the Fibonacci. So with Fibonacci, we can also do it the recursion. And we can use the multiple recursion. So when we use the word binary recursion means we have two. If we use the word multiple, actually it is more than one. So multiple recursion means more than one. So it can also include binary. It can also maybe more than two, and so on. One example, this is the Fibonacci. You can do Fibonacci without recursion. You can do Fibonacci with recursion. If it is without, you can use only for loop. But if you use with recursion, there are also some variants. You can use till recursion. But now I'm going to use the recursion, and I'm going to show you the multiple recursion. So what is the Fibonacci with multiple recursion? So this is the recursive algorithm for the Fibonacci binary. It means we have only two recursive calls. The input should be non-negative integer. And the output is k Fibonacci number, fk. So this is the function. F0 will start from 0. F1 will start 1. Fi will equals to Fi minus 1 plus Fi minus 2. This is for I which is greater than 1. So if the k equals to 1, then return k. So return 1. If not, then you will do the Fibonacci k minus 1 plus binary Fibonacci k minus 2. Now, if you see this one, is it good? It seems good because you can see this on this function. This is the same with this function. I minus 1, or which is k minus 1, and k minus 2, which is k minus 2. So based on this formula, it seems this is good because the range should be Fi minus 1 plus Fi minus 2. But actually this one is computationally expensive. Why? So when we are in the n0, at the first number, it is 1. At the second number, it is only one operation. But when we are in the n equals to 2, so this is the number of operation. The number of operation when n0 is 1, the number of operation when n1 is 1, and there will be another operation to do the addition. So it means there will be 3 operations. When n equals to 3, we can do the n2, which is 3 operation, n1, which is 1 operation, n plus 1 operation. And we have like 5 operations. When we have the n4, you can follow from the previous one. When it is n5, you can follow the number of operation. When it is n6, you can follow the operation. And when it is n7, and so on. If you look at this one, so the nk, let's say from n4. So the n1 is 1, but when it is n4, it becomes 9. When it is n4 and n8, it becomes 67. So what we can see from this one, that nk at least doubles every other time. So this 3 and becomes 5. So about double. 5 becomes 9. So it is almost double. 9 becomes 15. It is so almost double. 15 becomes 25. It is almost double. So we can say this is 2 power of k. So when the number of k is very huge, then it is exponential. So some cases it is good to use recursive, but some cases it is not good to use recursive. So using binary recursion does not guarantee to get a better function. So some case is good, some case is not good. So this is just a note for you to do the algorithm. So the better Fibonacci algorithm, you can just use the linear recursion. The linear recursion, we can just have something like this one. The input is non-negative, and then it is a pair of fk and fk minus 1. So if k equals to 1, then return k comma 0. If it is not, then let's make the linear Fibonacci with k minus 1. And then we want to get the I and j. So the result will be I plus j, comma. The proven code will be something like this one. So if n equals to 1, then return 0 and 1. So we will return 2 values. If not, then a and b equals to Fibonacci n minus 1. So this is the calling of the method. And you can print. So return means I want to return 2 values. The 2 values are the a plus b, and also I want to get the previous value, which is a. So you can see here, a is the previous value. So this is next value. Yeah, you can check this one on your Python environment. So this Fibonacci with the recursive, or this is the linear recursion. Okay, so this is the end of the recursion. You learn about the basic definition and the linear recursion and some recursion variant, which is the binary. You can see the tail recursion, the binary recursion. I skipped the multiple because it means multiple we can have more than one, or sometimes we can have more than two recursion. So the iteration and recursion, basically they are the same thing. But people say that using the recursion, it is elegant. Elegance means it is easy to understand the code. So you know the base. We can easily to know when the algorithm stop. The performance. So the performance, some of the problems can be solved efficiently using recursion, but others no. So you need to find the linear recursion. If you can find the linear recursion, then it will be good, or the performance will be better. If you do with the binary recursion, you need to check whether it is efficient. Debug ability. Do you know debug? Debug means when you have the code, you want to check one by one, line by line. So you want to check where is the error. You want to check where is the missing line and so on. So we can say this is the debug ability. So debug ability means some problems in recursion are difficult to debug when it occurs errors. So what we did before in this one, this simulation shows this is a debug ability function. So we can check one by one. So if we go to this line, what happened? If we go to this line, what happened? If we go to this line, what happened? Then you can see your errors clearly. So this is the meaning by debug ability. Okay, then let me stop here. I will continue after the bit.